Hey, hello guys, welcome to IQCIVILS IAS Academy, a great coach transforms life. Today, we are going to discuss about LIGO India. Why LIGO India was in news? Because recently, our Prime Minister, Mr. Narendra Modi, inaugurated the Laser Interferometer Gravitational Wave Observatory of India. That's why it is in news. You will get fair idea about the LIGO India Observatory in this session. This topic will be covered by me, Dr. Sachin Kadam, faculty at IQ Civils IAS Academy, Guwahati. This is our elite panel of faculties from Delhi that includes Sunil sir, Sachin sir, Anuj sir, Alok sir, Yogesh sir, Rizwan sir, Vikram sir, Nitin Kumar sir. See, we are starting our new batches which are offline as well as online from 25th May and 5th of June. These batches are available online and offline. For that, you just need to do register your seat. You can call on these numbers for registration. This is the number of our director, Mr. Anuj Singh. This is the number of our admissions manager, and this is our front office holder. This is our YouTube channel. Subscribe to this channel, like this video, share this video, and enjoy quality content on YouTube free of cost at IQ Civils IAS Academy by Sachin Kadam sir. This is the Google review given by the students to IQ Civils IAS Academy. So you can be rest assured about the quality and the content available at IQ Civils IAS Academy from from APSC as well as UPSC point of view. So what exactly LIGO India is? As I told you, Prime Minister Narendra Modi recently laid down the foundation stone of LIGO India on the occasion of National Technology Day, that is 11th May. Now, there is a probability two types of question will be asked on this topic in UPSC Prelims 2023. National Technology Day of India is celebrated on 11th of May because from 11th May to 13th May, in these 3 days, India tested 6 nuclear weapons in Pokhran, and it was India's second nuclear test. India conducted its first nuclear test in 1974, and we call that Smiling Buddha. It was also conducted at Pokhran, Rajasthan. The second nuclear test of India was conducted in 1998 from 11th May to 13th May, and this is known as Project Shakti. To remember this nuclear test, India declared 11th May as National Technology Day. So first point, remember which day is celebrated as National Technology Day? 11th May. Why 11th May is celebrated as National Technology Day? Because on this day India tested its second nuclear weapon, as well as now on the same day, but in the year of 2023, India, or Prime Minister of India, laid down one of the biggest scientific adventures in India, that is LIGO India Observatory Foundation Stone. Now, what exactly this LIGO India Observatory is? Here you go. First of all, what is the long form of LIGO? So, L for laser, I for interferometer, Li, G for gravitational waves, and O for observatory. So, laser interferometer gravitational wave observatory. That is the long form of LIGO. So, what is LIGO? It is the Advanced Laser Interferometer Gravitational Wave Observatory, or LIGO, at the center of the path breaking find. Now, what is the finding that we came across because of the LIGO observatory? The LIGO experiment is an example of extreme engineering chasing an impossible dream. There are Currently there are two LIGO observatories which are in working condition. Both are located in USA. The twin LIGO installations, one in Livingston, USA, Louisiana, and the other in Hanford, USA, Washington, are located 3,000 km apart, and these LIGO observatories are L-shaped. So the two blind L-shaped detectors with 4 kilometer long vacuum chambers. So remember, their shape is L and they contain vacuum chambers. LIGO observatories contain vacuum chambers. Vacuum chambers that can accommodate 11 Boeing 747-400 commercial airliners. So you can imagine the size of these vacuum chambers present inside the LIGO observatory. Now these LIGO observatories are used to detect gravitational waves. Okay, what are gravitational waves? I will explain you to one by one. What is the long form of LIGO? Laser Interferometer Gravitational Wave Observatory. What is the objective of LIGO? LIGO is used to detect gravitational waves. How many LIGO observatories are present in the world? Currently, only two operational LIGO observatories are present in the world. Both are located in USA. One is located at Livingston and another is located at Hanford. Okay. So here you can see built 3000 kilometer apart, operating in unison, though they are located 3000 kilometer away from each other, but they operate together to make the smallest measurement ever attempted by science, a motion of 10,000 times smaller than an atomic nucleus. And this motion is caused by the most violent cataclysmic events in the universe occurring millions of light years away. It can detect gravitational waves in a volume of 1 billion cubic light years, covering about 1 million Milky Way type galaxies. Now, no need to go in the details, but just remember, LIGO observatories are trying to achieve impossible feat, that is to detect gravitational waves, and gravitational waves are so weak that motion created by them is 10,000 times smaller than atomic nucleus. So you can imagine the weakness of the gravitational waves. When a gravitational wave comes through, it stretches space in one direction and squeezes space in the other direction. So remember, gravitational waves can stretch or squeeze space. Okay, by measuring the interference of the laser as they bounce between the different points, physicists can measure very precisely whether the space in between has stretched or compressed, and on that basis we say ki whether there is a gravitational wave or not. To detect a gravitational wave, we should be able to tell when something changes in length by a few parts in 10 to the power 23. LIGO makes the smallest measurement ever attempted, a motion 10,000 times smaller than an atomic nucleus. It's like trying to hear a song being hummed in a very, 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 very noisy party, which is nearly impossible. So till now, long form of the LIGO, objective of the LIGO, and location where exactly LIGO is located. I explained you. Now we are going ahead. LIGO is the world's most powerful observatory because see, it is nearly impossible to detect gravitational waves, and because this LIGO observatory is trying to detect the uh, very weak gravitational waves, it means that these waves are really weak, so this observatory is really powerful. It exploits the physical properties of light and space to detect and understand the origins of gravitational waves. So if these are gravitational waves, okay, if these are waves, I will say, if these are waves, it means they should originate somewhere, na? So if we can detect these gravitational waves, first point though, it is really difficult to detect gravitational waves because gravitational waves are weak. Second, these gravitational waves originate from some sources. So if we can detect very weak gravitational waves, we can easily find out the sources of the gravitational waves. What are the different sources of gravitational waves? So it exploits the physical properties of light and space to detect and understand the origins of gravitational waves. at the moment. There are two such observatories in the USA. I told you these are separated by a distance of 3000 kilometers that work in tandem to pick up these gravitational waves. And these two places are, one is Livingston and another is Hanford. Both are located in USA. Now these two are operational gravitational waves, but there are more gravitational waves across the world. Only issue is those gravitational waves are not operational. So where else gravitational waves are located, gravitational observatories are located, or LIGO observatories are located. So here you can see LIGO Hanford, LIGO Livingston, and LIGO in Germany. These are the three operational gravitational wave observatories. Then Virgo, it is located in Italy, and Kagra, it is located in Japan. These two gravitational waves are under construction, and now in 2023 we laid down the foundation stone of the LIGO India Observatory, so we are calling that planned. So three operational, two under construction, and one planned. This is the future of the LIGO observatories across the world. Okay, so here you go. You can see each LIGO detector consists of two arms. That's why it is L shaped, right? LIGO India will be the fifth node of this international network. First one is in Livingston, second one is in Hanford, third one is in Germany, fourth is in Italy, and fifth is in Japan. And India, they are saying it is fifth node, but it will be, yes, it will be fifth, because one of the LIGO observatory from USA will be transported to India. We are not creating new LIGO observatory. We are only relocating LIGO, one of the LIGO observatory from USA to India. Where in India? So it will be located in Maharashtra, India. Where in Maharashtra? It will be located in Hingoli district. Where in Hingoli district of Maharashtra? It will be located in the Aundha Nagnath Tehsil. And this Aundha Nagnath is one of the 12 Jyotirlingas. And for your information, this Aundha Nagnath Jyotirlinga is only 30 kilometers from my village. Currently, I am taking class from one of the district place. If possible, I will show you the location of the LIGO, future LIGO Observatory of India on Google Earth. I hope the Google is visible to you. World's most detailed globe. This is, here you go. I launched Earth. Okay, Google Earth is here. So I already launched one. So in this I will definitely show you. So remember, India LIGO Observatory will be located in Maharashtra's Hingoli district. Fine, let's go ahead. So I already told you operational, under construction, and planned. Now it is envisaged, this LIGO India is envisaged as a collaborative project between a consortium of Indian research institutions and the LIGO laboratory in the USA, along with its international partners. It will be built by the Department of Atomic Energy, very important. LIGO India Observatory will be built by, number one, Department of Atomic Energy, or DAE, and the Department of Science and Technology, that is DST, with a MOU signed with the National Science Foundation of the USA. So this will be done in collaboration with USA. Okay, we are constructing this LIGO observatory in collaboration with USA, along with several national and international research and academic institutions. Okay, LIGO India is a collaboration between LIGO Laboratory, operated by Caltech and MIT in USA, and three institutes in India. Again, very important. Now you know which two departments are involved. One is Department of Atomic Energy, another is Department of Science and Technology, and which institutes are involved. Number one, Raja Ramanna Center for Advanced Technology located in Indore, RRCAT. Number 2, the Institute for Plasma Research, Ahmedabad, IPR. And number 3, the Inter-University Center for Astronomy and Astrophysics located in Pune. Three organizations, two departments located in Maharashtra Hingoli district, that is India LIGO Observatory. When LIGO India is completed, it will join a global network of gravitational wave observatories that includes Virgo in Italy, Kagra in Japan, and GEO 600 in Germany, and LIGO in USA. These are the international observatories through to which Indian LIGO will be connected. LIGO India will provide opportunities for Indian youth to pursue research careers in cutting edge areas of science and technology. Just imagine, LIGO Observatory is one of the most advanced initiatives of the world, and you have seen LIGO Observatory is located in USA, it is located in Germany, it is located in Italy, it is located in Japan. So these observatories are located in only 4 countries across the world. India will be the 5th country with LIGO Observatory. There is no LIGO Observatory in Russia, in China, or in UK. Obviously, it will help Indian youngsters to pursue research career, and if more and more Indians start pursuing research career, obviously they will be they will take India much ahead. This is first significance. Number 2, it will lead to advancement in gravitational wave astronomy and astrophysics. It will help India to study astronomical events and astrophysical events by using gravitational waves. And it will lead to the development of cutting edge technologies, because constructing LIGO instruments is not an easy task. And obviously, for establishing this LIGO observatory or this LIGO initiative, India will need latest technology, and that latest technology will be made available by India. Clear? Let's go ahead. So this is the significance. First, research opportunities for Indians. Number 2, advancement of India in astronomical and astrophysical phenomenon. And number 3, cutting edge technology will be available to India. Now, what are gravitational waves? Actually, gravitational waves are the ripples. One by one, remember this very carefully. These are the ripples created in the fabric of space and time. Okay, these are the ripples created in the fabric of space and time. So I will show you actually what happens now. According to Einstein, the space between the space between Earth and Sun, to whom we call what we call that, we call this vacuum, but according to Einstein it is not vacuum. According to Einstein, the space between Sun and Earth, or between different celestial bodies, it is not vacuum, it is made up of fabric of space and time. And this fabric of space and time is like this. I will show you where it is. This one, this is our Earth, and this Earth is suspended in the fabric of space and time like this. Here you can see the vacuum or the space surrounded by Earth is made up of fabric of space and time. And in this fabric of space and time, when some ripples are created, so these ripples will create gravitational waves. Okay, so what is gravity according to Einstein? Gravity is the depression created in the fabric of space and time. And what is gravitational waves? These are the ripples created in the fabric of space and time. Let's go back. So what are gravitational waves? It is an invisible yet incredibly fast ripple in space. They travel at the speed of light, that is 186,000 miles per second. These waves squeeze and stretch, very important, a space can be squeezed or it can be stretched. Anything in their path as they pass by. So normally gravitational waves pass by or pass through the fabric of space and time. So they squeeze and stretch the space. That is gravitational wave. Now from where these gravitational waves come? So gravity, which is the depression created in the fabric of space and time, and gravitational waves, which are the ripples created in the fabric of space and time, both were predicted by Einstein in his theory of special relativity. Okay, so both are predicted by Mr. Einstein, one of the most talented human beings ever born on the earth. Let's go ahead. Einstein predicted that when two bodies, such as planets or stars, orbit each other, it causes ripples in space, and these ripples are known as gravitational waves. These ripples would spread out like ripples in a pond when a stone is tossed in. Scientists call these ripples of space gravitational waves. Okay, so now again a quick recap. What is gravity? It is the depression created in the fabric of space and time. What is gravitational waves? These are the ripples created in the fabric of space and time. Let's go ahead. And who predicted gravitational waves? Gravitational waves were predicted by the Einstein. Okay, now I will show you few facts and then I will sum up everything about the LIGO India Observatory. Okay, what is gravitational wave? You should know. What are gravitational waves? These are the ripples created in the fabric of space and time. From who generates these gravitational waves? These gravitational waves are generated by one of the most violent activities that happen across the universe. In our universe, some of the most violent activities happen, and these activities lead to the generation of the gravitational wave. So what are the sources of gravitational waves? Who creates gravitational waves? Actually, gravitational waves are created by each and every body which has a mass. But gravitational waves are so weak that we cannot detect gravitational wave generated by very small body. But yes, we can generate gravitational waves created by a neutron star. We can detect gravitational waves generated by the two neutron stars merging with each other or orbiting each other, two black holes merging with each other or orbiting around each other, or a neutron star and a black hole orbiting around each other or merging with each other. Okay, that is uh, gravity sources of gravitational waves. Even there are many sources which we are not aware, from which these gravitational waves are generated or these gravitational waves are created. If possible, if you can listen, this is the sound created by gravitational waves. Okay, and these gravitational waves were first detected in the year 2015, and these gravitational waves were detected by the LIGO located in USA. Okay, so this topic was related to the space. That's why I took two questions from the space technology from PYQ. In the year 2022, UPSC has asked a question, and the question is, which one of the following statement best reflects the idea behind the fractional orbital bombardment system often talked about in media? It is actually a missile put into stable orbit around the Earth and deorbits over a target on Earth. Normally, it is not allowed or it is banned to put missiles into the orbits. But recently, Russia sent a missile which is located in the orbit, and most probably Russia also used that missile against Ukraine. That's why this question was asked. So what is fractional orbital bombardment system? It is a missile that is put into a stable orbit around the Earth and deorbits over a target on the Earth. Okay. Then second, if a major solar storm or solar flare reaches the Earth, which of the following are the possible effects on the Earth? What will happen to Earth if a major solar storm or a solar flare reaches the Earth? So obviously, it will impact the GPS and navigation system. GPS and navigation system will fail. Then power grids could be damaged because power grids use navigation or satellite for transporting electricity from one place to another. Fourth, intense auroras could occur over much of the Earth. Then, orbits of the satellite could be disturbed. So, these four are the compulsory effect. Huh? Now, B is not the answer because 1 is not there. 1, 3, 4, and 6 should be there. So, in A is not the answer. 1, 3, 4, 6. C can be or D can be. So, actually, answer given by UPSC is C. 1, 3, 4, 6, and 7, solar flare or solar storm has nothing to do with the tsunamis because tsunamis are generated by the earthquakes, and forest fire has nothing to do with the solar storm or solar flare. That's why your answer is C. So there were many questions that are asked by UPSC in preliminary examination which are based on the gravitational waves, but took few questions which are related to the space. There is one more topic that is in news, and this topic can be asked in 2023 prelims. Actually, the thing is, recently uh, in Ludhiana, and within Ludhiana in Gyaspur, it is a place in Ludhiana. There was a gas leak, and because of the leaking of this gas, 11 people died. And which gas leaked? So the name of that gas is hydrogen sulfide. Okay, so this hydrogen sulfide gas was leaked in Ludhiana Gyaspur, that led to the death of the 11 people. That's why it is in news. So you should know what is hydrogen sulfide. So this hydrogen sulfide is released from hydrothermal vents. This hydrogen sulfide is released from cold ships by bacterial activity, and this hydrogen sulfide can be released from the volcanoes. Okay, these are the different sources of the hydrogen sulfide, natural sources of the hydrogen sulfide. Now, what is hydrogen sulfide? It is a colorless chalcogen hydride gas with a characteristic foul odor. It is a very poisonous, corrosive, and flammable gas. Remember, it is poisonous and it is flammable. It has foul odor. Then it dissolves in water and oil. Very important. Hydrogen sulfide gas dissolves in water and oil, and it may be released when these liquids are heated, depressurized, or agitated. It occurs in, as I told you, volcanic gases, natural gas, and some sources of well water. Even well water can contain hydrogen sulfide. What is the impact of hydrogen sulfide? It can cause mild headache. Okay, it can cause mild headache, it can cause eye irritation, and it can also cause unconsciousness or even death. So recently, hydrogen sulfide gas caused death. Okay, too much hydrogen sulfide can halt the breathing center in the brain, which can cause death. So the death of the 11 people in Gyaspur, Ludhiana, because of the leakage of the hydrogen sulfide is because of the impact of hydrogen sulfide on the breathing centers in our brain. Okay, so that is about the hydrogen sulfide. Uh, what are the other health health hazards हो गए? The gas can also irritate the eyes, nose, throat, and lungs because it is heavier than air. Hydrogen sulfide can collect in low-lying and enclosed spaces such as manholes, sewages, and underground telephone vaults. Its presence makes work in confined spaces potentially very dangerous. Then where it is used, number one, it is used in the production of sulfuric acid. Number two, it is also used to create inorganic sulfides. Number three, it is used in the production of pesticides, production of leather, production of dyes, and production of medicines. It is also used to produce heavy water in nuclear power plant, that is to create D2O. And last, it is also used or is a byproduct in many industrial processes. Though, remember, this can be directly asked in UPSC prelims: pesticide, leather, dyes, pharmaceuticals, heavy water in nuclear power plant, and the production of sulfuric acid. It is one of the most probable question of prelims 2023. Hydrogen sulfide is produced naturally from decaying organic matter. It occurs naturally in sewage, manure pits, well water, oil and gas wells, I already told you, and volcanoes. It can be released from sewage sludge, liquid manure, sulfur hot springs, and natural gas. These are the sources of hydrogen sulfide. Okay. This is a question asked by UPSC in prelims 2021, which is like bisphenol A. Very rare in news, but it was in news in 2021, so they asked a question in the same way in 2023. I assure you there will be a question on hydrogen sulfide. So bisphenol A, a cause of concern, is a structural or key component in the manufacturing of low density polyethylene. Remember. Okay. And second question, water can dissolve more substances than any other liquid because of its because it is a good conductor of heat. That's why it can dissolve more substances than any other liquid. Okay, again asked in 2021. So question from the you can say preliminary from the chemistry, applied chemistry you can say. So that's it for the today, guys. Next in next session we are going to discuss about the Pokhran anniversary, because 2023 is the anniversary, 25th anniversary of the Pokhran blast. So we will discuss that tomorrow. To get PDF notes of this class, join this Telegram channel. Register yourself for the batches that will be available on 15th May and that will start from the 6th June. Okay, these two batches. So register yourself by calling on this number and enjoy quality teaching at IQ Civils IAS Academy. Okay, so that's it from my side, guys. Thank you very much. Bye bye. Take care. Sayonara. See you in next video that is related to the Pokhran nuclear bomb explosion.